Okay, now we're going to look at the process of completing the square that's used to solve quadratic equations. This first part that I have here is actually just a part of completing the process or completing the square process. So we'll just kind of get used to a couple of steps right here, and then we'll actually go into solving the whole equation. Okay, so it says to determine the constant that should be added to the binomial so that it becomes a perfect square binomial, and then to factor. Okay, so we're going to, this first example, of course, we're going to turn it into a trinomial, which means we need to know the third term here, which is going to be a constant. So this is where the process of completing the square comes from. This formula, where you take your b value, divide it by 2, and then square it, that is going to give you the constant that you would need to have here to add to both sides in order to get what's called the perfect square trinomial. Now, if you remember, when you're dealing with a quadratic, your b value is the coefficient of x. So this is what you're going to use in this formula. So for this particular problem, your b value is 12. Okay, so that means I'll have 12 divided by 2 squared. So you go through your order of operations there. Of course, 12 divided by 2 is 6. 6 squared is 36. So this is going to be the number that's going to be added that gives me this perfect square trinomial. This is always addition because you're always squaring, which means this is always going to be positive. Okay, so that's the first thing it was wanting you to do. Then it says to factor. Now, this is a trinomial, so you're used to, of course, doing the two sets of parentheses. X squared is x times x. And what you would need to multiply to get the 36, but yet add to get the 12, is going to be a plus 6 and a plus 6. But any time that you have, as we do here, a perfect square trinomial, it always factors where the two binomials are identical to each other. So this would be equivalent to writing it this way. Okay, and actually when we go through the whole process in a few minutes on completing the square, this will be the way that we need to write it. But it is still just factoring as we have factored other things in the past. Okay, so there's the constant that needed to be added, and then when it said to factor, this is what it's looking for. Alright, going to go in through the second example. Here, your b value is negative 2/3. So we'll have negative 2/3 divided by 2 squared. So again, just go through the arithmetic there. That's going to give us negative 2 over 6 squared. Of course, that will simplify. You can take different steps here, but that would be negative 1/3 squared, which will now give us 1/9. So this will be the value that needs to be added. Now, when it comes to factoring, the fact that you've got the fractions in here, that doesn't make it nearly as easy to factor as the first one. So here's a couple of little hints. Now, I've already explained that when this is a perfect square trinomial, as this one was, the two factors are always going to be the same. So I'm going to take this one and actually go straight to just the binomial squared. So you can go ahead and put your parentheses, put your square. This is always just going to be x because the first term we're looking at here is always just going to be x squared. Now you're either going to have a plus or a minus. This first sign right here will determine that for you. Since this is a minus, this will be a minus. Just like here, this was a plus, this was a plus. So we know we need to put a minus. Now the other thing is the number that goes here will actually be what you ended up squaring. Now I know what we ended up squaring was a negative, but yet when you go to put it in here, just ignore the fact that it's negative and it's just going to be a 1/3. So see, same thing back over here. what number did I actually end up squaring was a 6. I mean, 12 divided by 2 gave me 6, and see, that's the number that ended up in there. So that's just a couple of things to kind of get you ready for completing the square. Okay, so the next is actually getting into solving this equation by completing the square. Now, when you're asked to do this process, you do want to have your constant on the opposite side of these two. So that part's already done for us here. Alright, so what I would want you to do is after this term, I want you to leave a space, like the blank that I just had a while ago. We're going to fill in the blank, and that's equal to the -8. Alright, so going through the steps as we did a while ago, this is your b value, the 6. So we're going to take half of it and square it. So of course half is 3, 6 divided by 2 is 3, 3 squared is 9. So this will be the value, just like what we put in the blank a while ago. Now, since we're going through the whole process of completing the square, you do have to add the 9 on both sides. I mean, that just goes back to what you've always been taught about equations. What you do to one side of the equation, you have to do to the other. So add 9 on each side. Okay, this will factor. So remember, it's always going to be where the two parentheses are the same. So go ahead and get in a habit of just writing it once to the second power. So this would end up being x plus 3. Remember, I told you this is always x. This sign always comes from here. And the number that goes here is the number that you squared, or what you got when you took half. So either way you look at it, you get the 3. Combine these two. So that gives you a positive 1. Now from here down, you're actually going to use a method that we've already talked about, which is taking the square root of both sides. So you take the square root of this side, since it's a parenthesis squared, so we have x plus 3. Of course, square root of 1 is just 1. Don't forget your plus minus. And last, you need to subtract the 3. Now, since this side happened to be a perfect square, I mean, I've just ended up with two real numbers here that I can actually combine. So do your two calculations. -3 plus 1 is -2, and -3 minus 1 is -4. So there's your two answers to that one. Okay, next. Now, this one doesn't have the constant on the other side like the one that I just finished, so that will actually need to be my first step on this one. Now, when I shift that over, though, go ahead and leave yourself a space right there to have, to add that number that we're going to figure out in just a minute. Of course, you're going to add the 5, so it's equal to positive 5. Alright, so my b value is -3. Take half of it and square it. Now this time my numerator, of course, is an odd number, so you can't divide and get a nice little whole number. So in a case like this, leave it in fraction form. So just leave it as -3 over 2, but now go ahead and square. So that's going to give us a positive 9 over 4. So I'm going to add 9/4. So remember, you got to add it on both sides. Okay, this side is going to factor. Okay, so remember the little shortcut here. The sign that I have here is here. And the number is going to be, again, what I ended up squaring, or what I had when I took half, which is the 3 halves. Remember, just ignore the negative in this case, because you've already determined that's got to be a minus. So it'll be 3 halves. Okay, so now we have to do the 5 plus the 9/4. Okay, let me figure that real quick. That is going to end up giving us 29/4. Okay, so now we're ready to use our square root property and take square root of both sides. So square root of this side would just leave me what's inside the parentheses. Now, in taking the square root of the fraction, you do numerator and denominator separately. So square root of 29 Of course, there's not any simplifying that you can do to that. And then square root of 4 is 2. So the radical's actually only left with the numerator. Okay, last, to get x by itself, add your 3/2. Okay, and there's your answer. Now the only other thing, like if you're checking your answer, they might possibly just write this all as one fraction, which is easy because you already have a common denominator. Like you would have 3 plus or minus square root 29 all in your numerator, and then you can just say all over 2. So that would be an equivalent answer. Okay, one more completing the square. And what's going to make this one different is the fact that I have a 3 here. If you glance back at the other two problems that I just finished, they both had a 1 in front. So if you do not have a positive 1 for your coefficient, you got to deal with that first. And whatever number you do have here, just go through and divide everything on each side by this coefficient. So what will happen is when you do your first term divided by 3, of course your 3's are going to cancel and you're just left with x squared. Okay, then I do have minus 5/3 x, since that won't divide evenly. And then I have minus 10/3. Of course, 0 divided by 3 is still just 0. Now at this point, I'm right back to where I was with the two previous examples because I do have the 1. Okay, you will want to add your constant to the other side. So that'll give me equal to a positive 10/3. Okay, my coefficient's negative 5/3. And then I need to take half and square. Alright, so doing the negative 5/3 divided by 2 is going to give me negative 5/6. And then I need to square the negative 5/6, which will give me 25 over 36. So add 25 over 36 on both sides. Okay, now this side's going to factor. Remember, minus sign here, so minus sign here. Okay, what I ended up squaring was the 5/6. That'll be the value that goes here. Okay, now we got to do the 10/3 plus 20 plus 25 over 36. Okay, so let me calculate this real quick. That will give me 193 over 3. Okay, so now we're ready to take square root of both sides. So x minus 5/6 is equal to plus or minus square root of 193 over 3. Now, neither one of these numbers are perfect squares like I had a while ago, so let's just leave it at this point for right now. Okay, last thing I need to do is add the 56. And there's your answer. Okay, so that is the end of completing the square.